Hello students, so today we're going to look at cube root functions, so the other half of the square root section. What you're going to want to have on you is your notes, graphs, pen or a pencil, and then also a calculator today. So let's take a look at this cube root graph. So f of x equals the cube root of x. What the graph's actually going to look like is something like that. So it's going to look kind of like a sideways S. If you turn your head, you'll see an S, or it kind of looks like an S right here. How our general table that we're going to use for this one. Cube roots, they can use negatives. So let's not forget about my negatives here. So we're going to use -8, -1, 0, 1, 8. That is going to be our general table, our parent table, if you will, for these ones. The square, or the cube root, excuse me, of -8, well, that's just -2. Cube root of -1, that's just -1. Cube root of 0, well, that's just, of course, 0. Cube root of 1, that is 1. And cube root of 8, well, that's just 2. So this is going to be our general table that we're going to use. Your domain, if you look at your x values, excuse me, your x values here, I use all negative x's and all positive x's. Whoa, that was a really bad R reals. There we go. All real numbers for that one. Your range. This is going to keep on expanding and getting bigger and bigger and bigger and bigger. Same on this side. So your range is also all real numbers. That is going to be always the case on cube root graphs. All reals for domain and all reals for range. Those are just like when we had for our parabolas, we always say all reals for domains. So this one is all reals for both domain and range. That's only for cube roots though. So remember when we talked about the shifting of square roots, and we had this similar thing. If you have a number outside of the cube root, that's going to move you up or down. Now remember, you're just going to want to have this part right here. Write down this part. You don't need this part, but we do need this part. That's going to give you a vertical shift up or down outside the main function. So this K tells you if you're going to move up or down or not. The little H there, he's going to say if you're moving left or right. Just like last time, it's opposite of what we think it should be. So if we see a minus there, we know we need to move to the right. So remember, it's always opposite when it's under the radical. The A tells you if you're going to stretch vertically or compress it vertically. And then number 4, of course, is the reflection. The negative in front, that's going to move you and flip you around the x-axis. Alright, so let's take a look at this one. We have the cube root of x minus 2 plus 1. So, very first thing I'm going to look at is how are these going to move my graph? The minus 2 under a radical, remember it's opposite of what we think it should do. So that's going to move us right 2. This plus 1 on the outside is going to move us up 1. So from 0, 0, we're going to move right 2, up 1. So, remember, our parent table looks something like this. So, this right 2, up 1, that's going to go in our 0 column right there. So then we need to ask ourselves, how did 0 become 2? What did I add to 0 to get 2? We added 2, right? So on each of these, we're going to add 2 to get our new x values. So -8 plus 2, that's -6. -1 plus 2, that is 1. 1 plus 2, that's 3. And 8 plus 2, well, that's just 10. So now we can plug these into our cube root functions. We got -6 minus 2 plus 1. -6 minus 2, that is the -8. Cube root of -8, well, that's just -2. So we're going to get a -1 for that one. Plugging in 1 here. Well, cube root of 1 minus 2, that's negative 1. So I'm going to have cube root negative 1 plus 1. Cube root of negative 1, well, that's just negative 1 plus 1. That actually is 0. So I have a point of 1, 0. Just showing my work here. If you understand what my work is going through, you do not need to have that work down on your paper. Cube root of 3 minus 2 plus 1. Just taking it, putting that 3 in for the x up there. 3 minus 2, well, that's just 1. Cube root of 1, that's 1. 1 plus 1, well, that's just 2. So I have 3, 2 for a point there. 10 minus 2 plus 1, that's cube root of 8 plus 1. Cube root of 8, that's 2, 3. So we're going to have the ordered pairs of negative 6, negative 1, negative 1, or no, 1, 0, 1, 0, right there, 2, 1, right there, we have that, 3, 2, right there, and 8, 3, right there. So our graph's going to look something like that. Remember, domain, all reals, range, all reals. Let's take a look at this one. We have the negative cube root of x plus 5. So this plus 5, if you remember, that's going to make us move left 5. So let's move left 5. Don't move up or down. So our, if I write my little parent table off to the side here, my 0 part is going to be negative 5, 0. So then I need to ask myself, how did 0 become negative 5? We subtracted 5, right? So each of these we need to subtract 5. So negative 8 minus 5, well, that is negative 13. Can't really graph that, but that's okay. Negative 1 minus 5, that's negative 6. Negative 4. Negative, oh, positive 3. Positive 3 there. So now, negative 13, if I pop it in and for my x, I'm going to get a negative 8, cube root of negative 8, negative 2, positive 2, because of that negative on the outside is going to cancel it out. Negative 6 plus 5, that's negative 1, cube root of negative 1, negative 1, negative, positive 1. Negative 4, it's going to give me a 1, cube root, 1, negative 1, and 3 plus 5, that's 8, cube root, 2, negative 2. So I have negative 13, 2, can't graph that. Negative 6, 1, I can graph. I can graph negative 5, 0, negative 4, negative 1, and negative 3, negative 2. Or no, positive 3, excuse me, negative 2, something like that. There we go. So it's going to be a graph that looks something like that. Domain, just like I said earlier, all reals, range, all reals. What about this one? The negative 2 times the cube root of x plus 1. So we're going to write this so it's a little easier to see. I'm going to make that the cube root of x plus 1. Otherwise, I forget that it's the cube root of x. This plus 1, it's going to move us up 1. So we're going to move up 1. So that's going to be my start point. So if I write like this, negative 1, 0, 1, 8, that's my parent function here. I'm going to start 0, 1. So how did 0 become 0? Didn't do anything. So I actually get to use my parent table on this one. Yippee! So cube root, let's actually write these out. This one's a little more difficult to think in your head. Cube root of negative 8, that's negative 2. So I have negative 2 times negative 2 plus 1. Negative 2 times negative 2, well, that's 4. 4 plus 1, that's 5. Negative 2 cube root of negative 1 plus 1. Cube root of negative 1, well, that's just negative 1. 2 plus 1, that's 3. Now I got this 1 here. So we got negative 2 cube root of 1 plus 1. Cube root of 1 is 1. So we got negative 2 times 1 plus 1. Negative 2 times 1, that's negative 2. Plus 1, that is negative 1. And negative 2 cube root of 8 plus 1. Cube root of 8, well, that's just 2. Negative 2 times 2, negative 4. Negative 3. So let's graph this. Negative 8, 5. Negative 8, positive 5, all the way up there. There we go. Negative 1, 3. Negative 1, 3, right there. 0, 1 I have graphed. 1, negative 1. And negative 3, or 8, excuse me, negative 3. There we go. So it's going to be something like... Nope, missed that one a little bit. That graph right there. Notice how I stretched it vertically, got stretched. So your domain, all reals again, range, all reals also. That's the end of the video. See you later.